Good evening, friends. Welcome to your favorite YouTube channel, Unacademy GATE MEPI XE. This is your educator, Aprup Rao, and this is the lecture series of Strength of Material in the booster batch for GATE 2021, 100 days crash course for all the GATE 2021 aspirants, where we are going to complete the entire syllabus within 100 days. And this is the lecture series of Strength of Material. This is the 7th lecture, and today we are going to see the problems related to axially loaded members. Yesterday we started calculation of stress and strain, and we are considering the one type of load, that is axial load. So beta, today we are going to continue that chapter and we are going to solve different varieties of problems related to axially loaded members. So I welcome all of you. Hit the like button and don't forget to share the link with your friends. Remember, sharing is caring. Now, those of you who are watching me for the first time, let me introduce myself. My name is Aprup Rao, All India rank 320 in GATE Mechanical. I've done my MTech from IIT Kharagpur and my specialization was design. Then I worked in the field of design as a deputy manager. I was at Mahindra Research Valley, where the cars and tractors of Mahindra and Mahindra are designed. The XUV 500, KUV, TUV, all these beautiful SUVs are designed at Mahindra Research Valley. So I was there for 2 years. Then I quit my job and I started teaching. I've been teaching for more than 6 years now for GATE and ESE aspirants, and I teach subjects related to design, SOM, MD, EM and TOM. But this is not important. What important is my passion and love for teaching and my love for the subjects of design. And if you are following my lectures regularly, then I can surely say that you will also fall in love with design and your concepts will be crystal clear. Now, a very important thing to notice, we have a lot of free initiatives for you guys on YouTube, on this very YouTube channel. So we have recently started the booster batch for GATE 2021, 100 days crash course. We are going to complete all the subjects within these 100 days, and we have started 3 subjects simultaneously: heat transfer at 7 a.m., engineering mechanics at 8:45 a.m. and strength of material by 7:30 p.m. to 9 p.m. Monday to Friday. So this is the booster batch 100 days crash course, and a very good news for all the second year and third year students. We are starting weekend batch from tomorrow. From tomorrow, we are launching weekend batch. For the very first time in the history of YouTube, we are launching a full-fledged weekend batch where the classes will be only held on weekends, Saturday and Sunday. So if you are a second year or a third year students and you are not able to manage between the college classes and GATE classes, then this is the best opportunity for you. We are launching 3 subjects simultaneously in this weekend batch: engineering mathematics at 9 a.m. to 12 p.m. then engineering mechanics from 2 p.m. to 5 p.m. and strength of material from 7 p.m. to 10 p.m. Now this is a completely different batch, a weekend batch where the classes will be only held on weekends. Saturday and Sunday we will have 3 hours of class each day. So beta, 6 hours of class for every subject. 6 hours of class for every subject on weekends. So beta, this is the best opportunity for all the second year and third year students. You can easily manage your GATE classes and your college classes. So we have a lot of YouTube initiatives, lot of free initiatives for you guys. All we need from you is your hard work, your dedication, your sincerity and your live attendance. And if you can, then please hit the like button in all these sessions and share the link with your friends. And if you find anything good or if you find any scope of improvement, then put it in the comment section. Okay, so this is all we want from you: spreading the information to all your friends, to all your colleagues, to all your classmates, so that everyone can take advantage of these initiatives. We want maximum number of students to be live in these classes because we are putting a lot of efforts into these classes. हम बहुत ज्यादा मेहनत कर रहे हैं इन क्लासेस को चलाने के लिए, हम बहुत ज्यादा टाइम और बहुत ज्यादा मेहनत लगा रहे हैं इन क्लासेस के पीछे. तो हम बस यही चाहते हैं कि ज्यादा से ज्यादा लोग इन क्लासेस को देखें, इन क्लासेस का फायदा उठाएं. That is all we want from you. So just a little cooperation and we can do wonders with these classes. मैं आप लोगों को बता रहा हूं कि हम में से ही कोई एक इन YouTube क्लासेस को देख के ही अच्छी रैंक लेके आने वाला है. So बेटा please share these videos, please share these informations with all your friends as maximum as possible. जितने ज्यादा लोगों से तक आप ये इंफॉर्मेशन पहुंचा सकते हैं उतना अच्छा, ठीक है. And if you want to download the ebooks and the PDF of my subjects, then just go to tinyurl.com/approved10. In this website, I have uploaded the ebooks of all my subjects. You will find the folders of engineering mechanics, machine design, strength of material, and you will also find 4 Excel sheets. In the first Excel sheet, you will find the link of all my Unacademy free special classes. So this is another free initiative for you where I take special classes on different topics, and I also take DPPs, daily practice problem sessions, on Unacademy. So beta, these are completely free. You can watch these lectures. Just open the Excel sheet and just go to the link. And we have 3 Excel sheets for 3 different subjects: machine design, engineering mechanics, and strength of material. If you open these Excel sheets, you will see that lecture by lecture, you can find the YouTube class link and the PDF link of all the lectures. Engineering mechanics, 38 lectures complete. Then machine design complete. Strength of material, we have just started on 1st of October. Till now, we have taken 6 lectures. This is the 7th lecture. You will find all those 6 lectures here, the YouTube class link and the PDF link. All you need to do is just go to tinyurl.com/approved10. I want this link to be viral. I want this link to be shared by each one of you. Thank you so much, guys. Thank you so much. Thank you so much, guys. Now, another very important thing, if you want to know the schedule of my YouTube classes and special classes, just follow my Telegram channel, join my Telegram channel, go to the Telegram app and search for Approved 10. Go to the Telegram app, search for Approved 10, or just scan this QR code and join this Telegram channel. You will get all the notifications of my YouTube classes and Unacademy free special classes. Whenever I will conduct DPP sessions, practice problem sessions, whenever we will practice the problems of strength of material, you will get the notification in this Telegram channel only. Okay, so join this Telegram channel today. All right. Now, yesterday we started the chapter of axially loaded members. We have seen the basic concept of stress, we have seen the basic concept of strain, we have seen the relation between stress and strain, we have seen the material properties involved in the calculation of stress and strain, and now we have started the calculation of stress and strain. अब हम लोग calculation part पे जा रहे हैं stress और strain के, और मैंने आपको बताया था, I have told you that in every chapter we will consider one particular type of load and we will see how to calculate the stress and strain under that loading condition. हमने कल डिस्कस किया था कि हर एक चैप्टर में हम एक पर्टिकुलर टाइप का लोड कंसीडर करेंगे और हम देखेंगे कि इस लोड से स्ट्रेस और स्ट्रेन की वैल्यूज हम कैसे कैलकुलेट करते हैं. यस, एंड वी स्टार्टेड विद द एक्सियल लोड. व्हाट इज एक्सियल लोड? इफ दिस इज अ स्लेंडर मेंबर, देन द एक्सियल लोड इज द लोड acting along the length of the member, right? This is the load acting along the length of the member. So this is known as axial load. Now, in order to calculate the stress and strain under this load, we made some assumption. The material is homogeneous and isotropic. The bar is of constant cross-sectional area. The axial load passes through the centroid of the cross-section, and the stresses are within the proportional limit. And I explained to you the meaning of each and every assumption. मैंने आपको कल समझाया था कि हर एक assumption जो है उसका क्या मतलब है और वो क्यों जरूरी है, right? Now, the equation of stress in this case is sigma equal to P by A, very easy, and the equation of the elongation यानी change in length is PL by AE, but this equation is only valid if P, A and E are constant throughout the length. If P, A and E are not constant, if any of these things are not constant, then how to calculate stress? By integration. So in today's class, we are going to solve such kind of problems where the load or the area is not constant throughout the length. आज हम इस टाइप के प्रॉब्लम्स करने वाले हैं जहां लोड या एरिया जो है वो कांस्टेंट नहीं होता है, वो वैरी करता है. तो उस केस में हम कैसे स्ट्रेसेस कैलकुलेट करेंगे, आज हम ये देखने वाले हैं. ओके, नाउ बेटा देयर आर टू very important parameters related to the deformation, and those are axial rigidity and axial stiffness. Okay, तो कल ये मिस हो गया था, so please note this down and understand the meaning. Axial rigidity का मतलब क्या है? What is rigidity? Rigidity means the resistance to deformation. Rigidity का मतलब क्या है? Resistance to deformation. So if the material, if the body is rigid, it will resist the deformation. जितनी ज्यादा rigidity उतना कम deformation. If rigidity is more, deformation will be less. So beta, you can see that axial rigidity is defined by AE. So if this AE is more, del L will be less. So this is axial rigidity. And what is axial stiffness? Stiffness का मतलब क्या होता है? Load divided by deformation. Load required for unit deformation. In case of spring, what is stiffness? F upon X, right? Force divided by deformation. Force required for unit deformation. मतलब 1 mm deformation के लिए कितना force चाहिए? So beta, here also the axial stiffness is same. For 1 mm delta L, how much force is required? So beta, what will be the equation? P upon delta L. P upon delta L will be equal to what? AE by L. Or you can say rigidity divided by L. AE by L. So this is axial rigidity and this is axial stiffness. You note this down beta. There can be theory questions based on this, and we will also use this in numericals. Numerical maybe we will need these terms. We will have to understand these terms: axial stiffness and axial rigidity. Okay. All right. Now, yesterday I gave you a few problems to solve. So I hope everyone at least tried to solve them. I hope, मैं उम्मीद कर रहा हूं कि सब लोगों ने कम से कम कोशिश की होगी सवाल बनाने की. मुझे फर्क नहीं पड़ता कि आपका आंसर आया या नहीं, सही आंसर आया या गलत आंसर आया है. मुझे इस बात से फर्क पड़ता है कि आपने अटेम्प्ट किया या नहीं. I care about whether you attempted this question or not. Whether you are getting the right answer or the wrong answer, I don't care. It doesn't matter to me, but attempting the question is important. Putting some efforts into the question is important. So let's understand how we can solve this problem. So we have a circular bar ABCD. Area is given. A and D are A and D is fixed, and at B and C we have these loads. Now we need to find the displacement of B, and in order to calculate the displacement of B, I will calculate the change in length from A to B. Now in order to calculate change in length, we need internal resistance, and in order to calculate internal resistance, we need reaction, है ना? यहाँ पे reaction जो आ रहा है, अगर वो नहीं पता तो मैं internal force नहीं निकाल सकता, और internal force नहीं है तो मैं change in length नहीं निकाल सकता. So it is very important to find the reaction at this end A. So how we can find that reaction? Let's see that. So beta, first of all, I will assume any one direction of this reaction. So let me say that this is RA. Let me say that this is RD. Although I don't need RD, मुझे RD की जरूरत नहीं है, but still let's say this is RA and that is RD. Okay. Now, in order to calculate the value of RA, I will apply the compatibility equation. If you want both of these, अगर RA और RD दोनों चाहिए, then you will need equilibrium and compatibility. But if I want only RA, I will directly use the compatibility equation. And what is the compatibility equation? What is the compatibility equation? Delta L of AD will be 0. Total change in length from A to D will be 0. Then beta, if total change in length from A to D is 0, can I say delta L of AB plus delta L of BC plus delta L of CD is 0? AB plus BC plus CD? Yes. Now, Can I find the internal force in AB in terms of RA? Take one section in AB. What will be the internal force on the left? Total force on the left कितना होगा? RA. And this is my assumption that RA is like this. So it is tensile. So beta RA multiplied by what is the length? 1500 divided by what is the area? 1000 multiplied by Young's modulus को मैं E लिख देता हूं because right now I don't need E. Okay. Plus change in length of BC. So beta let's consider a section between B and C. So on the left of this section, what is the total force? RA minus 50 kilonewton, right? RA minus 50 kilonewton. So let me write it like this. RA minus 50 into 10 to the power 3 multiplied by what is the length? 2000 divided by what is the area? 1500 mm square multiplied by Young's modulus E. Then internal force in CD. So take any section in CD. What will be the total force on left? RA minus 50 minus 150. So it will be RA minus 200 kilonewton, right? RA minus 200 kilonewton multiplied by what is the length? 1500 mm divided by what is the area? 2000. Young's modulus E equal to 0. So you are getting this equation, and if you solve this equation, you are going to get the value of RA. If you solve this equation, you are going to get the value of RA. If your answer is very small or very large, that means you must be doing some mistake in the units. Units का ध्यान रखो, units का ध्यान रखो, ठीक है? धर्मेंद्र, I have already explained what is the meaning of displacement, ठीक है? कल ही हमने डिस्कस किया था डिस्प्लेसमेंट का मतलब क्या होता है, डिफॉर्मेशन या डिस्प्लेसमेंट बोल रहा हूं किसी पॉइंट का, तो उसका मतलब क्या होता है. Now in this equation there is only one unknown RA, so you are going to get the value of RA by solving this equation. So I want every one of you to solve this equation quickly. Quickly इसको solve करके मुझे बताओ कि क्या आंसर आ रहा है. I will solve this equation in my calculator. Please solve this equation in your calculator and quickly tell me what is the answer. I have a calculator which can solve the equation. So if you have the calculator which can solve the equation, use that, or you can use the scientific calculator that will be given in the gate. So RA value is 60.465 into 10 to the power 3. Is it 60.465 into 10 to the power 3? RA is 60.465 into 10 to the power 3 Newton. Are you getting this? Are you getting this? क्या आपको ये आंसर मिल रहा है? Are you getting this? RA equals to 60.465 into 10 to the power 3 Newton. Yes, very good Ashwin, बहुत बढ़िया. Very good. 60.465 into 10 to the power 3. Okay. Now, I want the displacement of B. So, beta, what is going to happen? RA is positive. RA is positive. My RA is positive means my assumption is right. RA is positive. So, it is in this direction. So, there will be tension. So, beta, ये B जो है, it will go to B dash. So if I calculate change in length from A to B, it will give me BB dash, displacement of B. I need BB dash, displacement of B. So BB dash is going to be equal to delta L of AB, which will be 60.465 into 10 to the power 3 multiply length of AB, which is 1500 mm. I have to put everything in Newton and mm. Divided by area 1000 mm square multiplied by Young's modulus 200 gigapascal. कन्वर्ट इट इनटू मेगा पास्कल, तो ये हो जाएगा 200 इंटू 10 टू द पावर 3. 1 गीगा पास्कल इज 10 टू द पावर 3 मेगा पास्कल, न्यूटन पर एमएम स्क्वायर. So everything is in Newton and mm. Okay, so from here you are going to get the value of delta L of AB, or you can say BB dash. So how much is it? कितना आ रहा है? How much is it? How much is it? कितना आ रहा है? 60.465 into 10 to the power 3 into 1500 divided by 1000 into 200 into 10 to the power 3. So it is 0.453 mm. 0.453 mm. So this is my answer. So are you guys getting the same answer? क्या सबका यही आंसर आ रहा है? Yes, Naveen, Krishna, Prasad, Yashwant, Sahim, Samuel, all of you are getting the same answer. Atharva, are you getting the same answer? Yes, very good guys, very good. Snigdhanjali, very good. Prasad, very good. Deepak, बहुत बढ़िया, बहुत बढ़िया. Why the attendance is so less? What have I told you in the first class? मैंने आप लोगों से इतने बार रिक्वेस्ट की है, keep sharing these links, keep sharing these links with your friends. If you don't do that, then attendance daily will be less and less and less, and that will be reflected in my energy here. If you don't want my energy to drop, please don't let the attendance to drop. अगर आप नहीं चाहते कि मेरी एनर्जी कम हो, तो फिर अटेंडेंस भी कम नहीं होनी चाहिए ना. अटेंडेंस डेली बढ़नी चाहिए यार, नए नए लोग डेली जुड़ने चाहिए. अटेंडेंस डेली कम होगी तो कैसे चलेगा? कैसे चलेगा? एनर्जी भी कम हो जाएगी दोस्तों. तो आप चाहते हो मेरी एनर्जी कम हो? नो. Yes, yes, okay, okay, okay. What to do if it asked at C? Beta Akhil, yesterday's class, watch the yesterday's class. I have already explained how you can calculate the displacement. उसके बावजूद आप पूछ रहे हो, if you want to calculate displacement of C, what you will do? You will calculate the deformation from A to C, or you will calculate the deformation from C to D. Total change in length. या तो A से निकालो या तो D से निकालो. मैंने कल पहले ही बोला था कि एक फिक्स पॉइंट से लेके यहां तक का चेंज इन लेंथ निकाल लो. Okay, so this question is clear. Now I told you to attempt this question also. Now this is also a statically indeterminate problem. So let's see how we can solve this problem. Okay, so we have a rigid beam AB which is hinged at A and subjected to a force of 48 kilonewton at B, and it is supported by a steel rod and a bronze rod at this point and this point. And we need to find the reaction force at the hinge. Now in order to find the reaction force at the hinge, you will first draw the free body diagram, है ना? अब बेटा free body diagram अगर मैं बनाऊं इसका, तो मुझे क्या मिलेगा? Let's see. At the reaction, at the hinge, there will be a horizontal reaction and a vertical reaction. ठीक है? Now it is connected to the steel rod and bronze rod. So beta, there will be a force in steel, there will be a force in bronze, right? Now beta, how many unknowns do we have here? यहाँ कितने unknown दिख रहे हैं? 1, 2, 3, 4. How many unknowns do we have? 4 unknowns. And how many equilibrium equations do we have? We have only 3 equilibrium equation. हमारे पास 3 ही equilibrium equation है. We have summation of fx equals to 0. We have summation of fy equal to 0. And we have summation of m equal to 0. So we only have 3 equilibrium equations and we have 4 unknowns, 2 reactions here, 1 here and 1 here. So beta 4 unknown forces and only 3 equilibrium equations. So this is a statically indeterminate system. This is a statically indeterminate problem. Is this clear to everyone? Is this clear to everyone? Why this is statically indeterminate? Is this clear to everyone? Yes? Yes? Very good beta, very good. Now beta, in order to calculate these forces, I need a 4th equation, and that 4th equation will be the compatibility equation. Okay, First of all, let's apply the equilibrium equation. Now summation of fx equals to 0 से मेरे को क्या मिलेगा? This will become 0. From summation of fx equals to 0, there is no other force in x, so this will become 0. Let me call it Ra, ठीक है? Let me call it P of steel. Let me call it P of bronze. Okay. So beta, now from summation of Fy equal to 0, what you are going to get? Summation of Fy equal to 0 say I will get Ra plus Ps plus Pb will be equal to what? 48. है ना? Ra plus Ps plus Pb will be equal to 48 kilonewton. है ना? So this is another equation. This is the second equation. Now third equation, summation of m. So beta, where I will take moment? I will take moment at A. If I take moment at A, what am I going to get? Summation of m, summation of m at point A. So if I take moment at point A, then the moment of this Ra will be gone. I will get Ps multiplied by 0.8 plus Pb multiplied by 1.6 plus 0.8. How much? 2.4 equal to 48 kilonewton multiplied by what is the total distance? 0.8, 0.8, 1.6 plus 1.6, 3.2, right? So this is another equation. Now I need a third equation, fourth equation. एक equation से ये 0 हो गया, then this, then this. Now I need another equation. So that another equation will be the compatibility equation. Now what will be the compatibility equation? Understand. Okay. In order to understand the compatibility equation, we need to understand how this is going to deform. Okay. So beta, what I want you to do is look at this. This is the bar, है ना? AB. ये अपना bar है. This is A and this is B. ठीक है? This is the bar AB and it is subjected to a force here. So if I apply a force here, then what will happen? This bar is hinged at A. So it is going to rotate about this hinge, right? This bar is hinged at A, so it is going to rotate about the hinge. So beta, finally it will become like this, right? Finally it will become like this. Now beta, see. Initially the steel rod was here. Let's call this point as C and let's call this point as D. So initially C was here. Initially C यहाँ पे था, अब C यहाँ पे है. And initially D यहाँ पे था, अब D यहाँ पे है. Now what is this beta? What is this? What is this? ये क्या है? This is the change in length of steel, right? This is the change in length of steel. अगर ये C point यहाँ पहुंच गया, मतलब स्टील की रॉड जो है वो इतना elongate हो रहा है, right? This much steel is elongating. So this is what? This is the change in length of steel. And this is what? This is what? D was initially here and now it's reached to here. So this is the change in length of bronze, right? So this is delta L of bronze. Now can I calculate a relation between delta L of steel and delta L of bronze? From similar triangle property, this length is how much? 0.8 and this length is how much? 1.6. ठीक है? हालांकि वैसा दिख नहीं रहा है, गलती से मैंने थोड़ा ज्यादा ले लिया है C को, but let's say, so what will be your compatibility equation? What will be your compatibility equation? Your compatibility equation will be delta L of steel divided by 0.8 equal to delta L of bronze divided by, यहां से यहां तक का टोटल बेस कितना होगा? 2.4. 4. I am applying the similar triangle property. Do you understand? This height by base equal to this height by this base. So delta L of steel by 0.8, delta L of bronze by 2.4. So I can write delta L of steel will be equal to delta L of bronze divided by 3. ये divided by 3 हो जाएगा ना, 0.8 ये हो जाएगा 3. So now put the value of delta L of steel and delta L of bronze. तो बेटा delta L of steel क्या हो जाएगा? What is the force in steel? I am assuming it to be PS. What is the length of steel? Length of steel कितना है? What is the length of steel? It is 1.2 meter. What is the area of steel? Area of steel कितना है? What is the area of steel? कहाँ दिया हुआ है? Area of steel, cross sectional area of steel is 850 and bronze is 650. ठीक है, तो ये हो गया आपका 850 and Young's modulus of steel is how much? Young's modulus of steel is 2 times of bronze. तो मैं इसको लिख देता हूं 2 times of bronze. Okay, equal to force in bronze is PB, length of bronze is how much? 2.4 meter. तो ये हो गया 2.4 into 10 to the power 3, area 650 and Young's modulus EB. So is this thing clear to everyone? Is this thing clear to everyone? क्या ये चीज clear है? क्या ये चीज clear है? Yes, very good, very good. Hit the like button guys. आज 200 के पार पहुंचाओ कम से कम. Hit the like button everyone please. So now beta, this thing is clear how I got the compatibility equation. Okay, now solve this equation and you will get the equation between PS and PB. आपको PS और PB के बीच में एक रिलेशन मिल जाएगा. तो ये EB गया, ये 10 to the power 3, ये 10 to the power 3 गया, 1.2 ये हो गया 2. ठीक है, तो ये 2 into 2 हो गया 4. तो बेटा ये हो जाएगा कितना? How much? 4 into 850 divided by 650. 5.23. PS will be equal to 5.23 of PB. So beta, this is another equation I am getting. So are you guys getting the same thing? Are you guys getting the same thing? PS equals to 5.23 times PB. Okay. Sorry. Divided by 3 miss हो गया है. Very good. Divided by 3 miss हो गया है. Divided by 3 miss हो गया है. Yes. तो ये 5.23 फिर डिवाइडेड बाय 3 भी होगा 1.74. ये यहां वाला डिवाइडेड बाय 3 यहां लगाना मैं भूल गया था. तो 1.74 आ रहा है. यस, 1.74 टाइम्स ऑफ पीबी. यस, चलो. सो नाउ बेटा PS एंड PB के बीच में वी हैव दिस रिलेशन and we have that relation. So by solving this and this, let me say this is equation number 1, this is equation number 2 and this is equation number 3. So by solving equation 2 and 3, I will get PS and PB. कितना आ रहा है PS? How much PS are we getting? So PS equal to 1.73 times of PB. So if I put it, how much I will get? 48 into 10 to the power 3 into 3.2 divided by 1.73 into 0.8 plus 2.4. So I will get PB equal to 40.59 into 10 to the power 3. 40.59 into 10 to the power 3, and if it is 40.59 into 10 to the power 3, 1.74 था क्या? एक सेकेंड. 48 into 10 to the power 3 into 3.2 divided by 1.74 into 0.8 plus 2.4. 40.5. ये हो गया 40.5. और अगर ये 40.5 है तो 40.5 multiplied by 1.74, this is 70.5. This is 70.5 into 10 to the power 3. So we have got PS and PB. Now from equation 1 I will get RA. Equation 1 से अब मेरे को RA मिल जाएगा. From equation 1 RA is how much? RA is 48 kilonewton minus PS minus PB, है ना? So how much RA am I getting? How much RA am I getting? How much RA am I getting? कितना आ रहा है? How much RA am I getting? 48 minus 70.5 minus 40.5 minus 63 into 10 to the power 3 Newton. Negative sign क्यों? Negative sign क्यों? Negative sign means my direction is wrong. Negative sign means the direction I have taken is wrong. It will be downward. I have considered RA to be upward. मैंने RA को upward assume किया था. It will actually be downward. है ना? RA is actually downward. Yes. So everyone is getting this answer. Everyone is getting this answer. चलो बहुत बढ़िया बहुत बढ़िया बहुत बढ़िया. So बेटा, this is how we can solve this problem, this type of problems, and you will see this type of problems in GATE. There are two questions of this type in GATE where there is a rigid beam hinged at one point and it is connected to two wires or two bars or two rods, and in order to get the compatibility equation we draw this diagram. So we will get the compatibility equation by similar triangle. Okay, so you will see these types of problems in GATE. ठीक है, इस टाइप के प्रॉब्लम आपको गेट में भी देखने को मिलेंगे. ठीक है, चलो चलो. सो बेटा लेट्स मूव ऑन टू द नेक्स्ट टॉपिक. नाउ बेटा we have solved statically indeterminate problems of different types. This is another type of statically indeterminate problem. Now understand how to solve this problem. A suspended bar consists of two cross sections as shown. ठीक है, एक suspended bar है, वो दो अलग अलग cross section का बना हुआ है. Initially its lower surface is 0.8 mm above the ground. Okay, so the lower surface is not touching the ground, it is 0.8 mm above the ground. A load of 40 kilonewton is applied here. Take E equal to 205 gigapascal. The reaction at the lower support is. The reaction at the lower support is. So beta understand the problem here. In the last to last problem, यानी कि इस प्रॉब्लम में, इस टाइप के प्रॉब्लम में the body was fixed at both the ends. The bar was fixed at both the ends. So the change in length was 0 and you were getting reactions at both the ends, right? But here understand what is going to happen. Understand the mechanism here. Okay, यहाँ पहले तो questions को समझो, question में क्या हो रहा है वो समझो. Okay, so beta here I am applying a 40 kilonewton load. Okay, let's say this point is A, this point is B, and this point is C. So understand what is happening here. When I apply a 40 kilonewton load here, then this AB will start to elongate. There will be no deformation in BC because there is no internal force in BC. BC में अभी internal force है क्या? Right now is there any internal force in BC? If I take a section, then below this section there is no force. Right now there is no reaction. अभी यहाँ पे gap है. Right now there is no reaction. So right now there is no deformation in BC. There will be deformation in AB. If I take a section in AB, then beta there will be a 40 kilonewton force, right? Now understand, when this AB will start to elongate, जब AB elongate होना चालू होगा, then this BC will move down, है ना? Due to the elongation of AB फैलेगा, तो BC भी move करेगा, and this C will get close to this, है ना? Now until and unless this C will elongate more than, this C will move more than 0.8 mm, there will be no reaction. जब तक ये C 0.8 mm से ज्यादा नीचे नहीं जाता, यहां से रिएक्शन नहीं आएगा. Understand, when do you get the reaction force from here? When the C will try to move more than 0.8 mm, है ना. अगर ये C 0.8 mm से ज्यादा मूव करने की कोशिश करेगा, तब जाके यहां से रिएक्शन आना चालू होगा. If this C moves equal to 0.8 or less than 0.8, there will be no reaction from the ground. C पे तब तक रिएक्शन नहीं आएगा, there will be no reaction at C until and unless C moves more than 0.8. If it moves equal to 0.8, still there will be no reaction, because C will just touch the ground. Just touch the ground, it will not apply any force on the ground. When C will apply force on the ground, when it will move more than 0.8, C will apply a downward force on ground, ground will apply an upward reaction at C. So right now there is no reaction at C. In order to find whether there will be a reaction at C or not, you will have to find out how much change in length of AB will there be. Change in length of AB कितना होगा? तो initially change in length of AB कितना होगा? Initially I am saying, right now there is no reaction at C. So in this condition, what will be the change in length of AB? It will be 40 kilonewton multiplied by length will be how much? 1200 divided by area 80, Young's modulus 205 into 10 to the power 3. So beta, how much change in length am I getting? How much change in length am I getting? 40 into 10 to the power 3 into 1200 divided by 80 into 205 into 10 to the power 3. So I am getting 2.93 mm. I am getting 2.93 mm, which is greater than 0.8 mm. So that means this will try to move past 0.8. तो बेटा अब मैंने ये चीज प्रूव कर दी. Now I have proven this that there will be reaction at C. अब इसका कोई काम नहीं है. Now this has nothing to do with the solution. I was just checking whether there will be a reaction at C or not. अगर ये 0.8 के बराबर आता, if this was less than 0.8 or equal to 0.8, then there will be no reaction at C and your answer will be 0. But right now it is more than 0.8, so there will be a reaction at C. There will be a reaction at C. तो बेटा अब देखो ये सवाल कैसे बनेगा. I will get a reaction at A like this. I will get a reaction at C like this. Okay. Now this is just my assumption. If you want, you can take RC downward. It doesn't matter. आप RC को कैसा भी ले सकते हो. I told you that this is just an assumption. If you are getting a positive answer, means your assumption is right. If you are getting a negative answer, means your assumption is wrong. So this is purely assumption. This has nothing to do with the right or wrong direction. Okay, तो आप कुछ भी direction assume कर सकते हो. Answer positive मतलब सही, negative मतलब आपका direction उल्टा है. ठीक है. Now बेटा, what I am going to do is I am going to find the value of RA by compatibility equation. What is the compatibility equation here? Understand. Compatibility equation यहाँ पे क्या होगी? What will be the compatibility equation here? Understand. You don't need to get confused. Very simple compatibility equation here. Here delta L from A to C, delta L from A to C will be equal to this gap 0.8. अगर ये गैप नहीं होता and it was fixed, तो delta L would have been 0. But now there will be a change in length of 0.8 mm. After 0.8 mm, your change in length will become 0. So maximum change in length will be 0.8, and this will be equal to delta L of AB plus delta L of BC equal to 0.8. अब delta L of AB कितना होगा बेटा? Force in AB will be how much? RA. Length of AB will be how much? 1200 mm. Area of AB will be how much? Area of AB is 80. Young's modulus 205 into 10 to the power 3 plus delta L of BC. अब बेटा BC में if I take a section, then बेटा total force will be RA minus 40 kilonewton. RA minus 40 kilonewton. Length of BC 2.4 meter. So this will be 2400 divided by area of BC. How much? 160 mm square into Young's mod, sorry 10 to the power 3 नहीं आएगा, into Young's modulus 205 into 10 to the power 3 equal to 0.8. I have put everything in Newton and mm. I have put everything in Newton and mm. Now just solve this equation and you are going to get RA. Solve this equation and you are going to get RA. So RA into 1200 divided by 80 into 205 into 10 to the power 3 plus RA minus 40 into 10 to the power 3 multiplied by 2400 divided by 160 into 205 into 10 to the power 3 equal to 0.8. So if you solve this equation, then you are going to get RA equal to 25.46. RA will be 25.46 into 10 to the power 3 Newton. Are you getting this? Are you getting this? Are you getting this? 25.46 into 10 to the power 3 Newton. And if RA is 25.46 into 10 to the power 3 Newton, then how much will be RC beta? यहाँ पे कितना होगा? RA plus RC equal to 40 किलो न्यूटन ना? RA plus RC equal to 40 किलो न्यूटन. तो RC कितना आएगा? 40 minus 25.46. 40 minus 25.46. So it will be 14.54. It will be 14.54 into 10 to the power 3 Newton. So this is the reaction at C and my answer is positive. Means my assumption is right. My assumption is right. It will be upward only. Okay. Is it clear? Is it clear? क्या ये clear है सबको? Is it clear? Is it clear? Yes. Very good, beta. Very good. So, beta, you don't need to put any other logic. Okay. Simple compatibility equation will be delta L of AC equal to 0.8 mm. Forget anything else. Ki first this will elongate, then this will come down, then this will happen, then that will happen. You don't have to put that logic. Just simple compatibility equation. Delta L of this complete bar will be 0.8. That's it. Everything is in this equation only. So you don't have to assume the initial condition, then final condition. You don't have to write the compatibility equation in stages. कि पहले A भी बढ़ेगा, फिर ये कम होगा. You don't have to do that. Okay. You have to write the compatibility equation in the final condition. So final condition में there will be a change in length of 0.8 mm. That's all you need to use. That's it. Nothing else. Is this clear? Is this clear? So this was done only to check whether there will be a reaction or not. Otherwise there is no use of this calculation. इस equation को, इस value को I have used nowhere else because this value is wrong. Actually there will be only 0.8 mm deformation. After that the deformation will stop. Right? So beta this is wrong actually. Okay. क्योंकि delta L of AB में force will not be only 40 kilonewton. Right? After this reaction will come, the force will now become RA, not 40 kilonewton. ठीक है? So beta don't have to put any other equation. Okay? चलो, चलो, चलो. So beta we have seen different types of statically indeterminate problems. Statically indeterminate problem जितने type के भी exam में आ सकते हैं, हमने सारे type के देख लिए हैं. Okay? Now let's move on to different types of axially loaded member. So now today we are going to find elongation of circular tapered bar. We are going to find elongation of rectangular tapered bar. We are going to solve problems of tapered bar. We are going to find elongation of bar due to self weight. We are going to find elongation of bar, conical bar due to self weight. So beta we are going to solve very interesting questions today. ठीक है? इसके बाद we have some numericals also based on this. Okay? So right now beta let's see how to find elongation of circular tapered bar. Okay, so we have a tapered bar of circular cross section. Minimum diameter is D1, maximum diameter is D2, and it is subjected to a tensile force P. Now in this case, I can't use this equation delta L equal to PL by A. This is wrong. Why? Because the area is not constant. This equation is only applicable if the area is constant like this. But this is a tapered bar. Area is not constant, so I can't use PL by A directly. Now understand what I am going to do in this problem. So in this problem, I am going to consider a very small element. मैं क्या करने वाला हूं, एक बहुत ही छोटा सा एक एलिमेंट कंसिडर करने वाला हूं, एक बहुत ही छोटा सा एक एलिमेंट कंसिडर करने वाला हूं, like this. I will consider a very small element like this. Okay, now take this element out. इस एलिमेंट को हम लोग बाहर निकाल लेते हैं. Take this element out. Okay, this is the element. Now this element will also be subjected to force P, right? This element will also be subjected to force P. Okay, now the length of this, sorry, I will assume that this element is at a distance. I will assume that this element is at a distance of x and the thickness of this element is dx. तो ये जो इसकी thickness है या आप बोल सकते हो इसकी length है, it is dx. Okay, now understand, if the thickness dx is very small, if I am considering a very small element, then can I assume that the diameter of this element is almost constant? Can I assume that this diameter d is almost constant? क्या मैं ये assume कर सकता हूं? Right now, actually the diameter is changing from left side to right side, d1 to d2. But if I consider a very small piece, एक बहुत छोटा सा टुकड़ा consider करूं, can I assume that diameter is almost constant? Right? So beta, can I write the equation of change in length for this element as this? P into, what is the length? Length is dx. What will be the area? Area will be pi by 4 d square, right? The area will be pi by 4 d square. This will be the area, na? ये area होगा pi by 4 d square multiplied by E. So what is this? Change in length of this very small piece. And beta, how many pieces will you have? From here to here, we will have infinite pieces. So if I add the change in length of all these pieces, I will get the total change in length. Now adding infinite pieces means what? Integrating, right? Integrate करना मतलब addition करना ही तो होता है. Infinite का addition करना ही तो होता है. So beta, if I add the change in length of very small infinite pieces like this, I will get change in length. Means if I integrate this equation from 0 to L, I will get the total change in length. But the problem is, if you want to integrate this equation, you need the value of d in terms of x. P is constant, E is constant, but d is not constant. You will get some equation of d in terms of x. So you need to find that equation of d. So how can we find the equation of d? How can we find the equation of d? Understand beta, how can we find the equation of d? कैसे find out करेंगे d की equation? So this is the tapered bar. This is the tapered bar. ठीक है. Now beta, this is the center line. Okay. Now I want you to draw a line from here. I want you to draw a line from here. Okay. अब beta understand. Okay. This is d. This total change in length, this total diameter is d. So how we can find the value of d? ये टोटल जो है ये d है, इसको निकालने के लिए मेरे को क्या चाहिए बेटा? From here to here I know, from here to here this is d1. So if I add this very small distance and this very small distance in d1, I will get d. And how we can find this very small distance? What will be this? What will be this? ये total कितना है? This is d2, this is d1. So this will be d2 minus d1 by 2, right? Let's call it h. तो ये भी हो जाएगा h. Okay. So how I can calculate h beta? Similar triangle. What is this? This is x. What is this? This is L. So can I apply similar triangle? H by x equal to d2 minus d1 by 2 by L. तो यहां से h कितना आ रहा है? How much is h? d2 minus d1 by 2L into x. This is h. So what will be d? d1 plus h plus h. 2h. So d will be equal to how much? d1 plus 2 into h, मतलब ये हो जाएगा d1 plus d2 minus d1 by L into x, right? So this is the value of d. This is the value of d. This is the value of d. d1 plus d2 minus d1 by L into x. This is the value of d. Yes. Now, once I have got the value of d in terms of x, I will put it here and I will integrate it. So beta, this will become like this. Delta L equal to integration 0 to L p dx divided by pi by 4 d1 plus d2 minus d1 by L into x का whole square into e. And if I integrate this equation and put the limits, I am going to get this equation p into L upon pi by 4 d1 d2 into e. This is the equation you are going to get. PL upon pi by 4 d1 into d2 into e. If you want, you can integrate it your own. Okay, खुद से आप integrate करके देख सकते हो. d1 plus d2 minus d1 by L into x. You consider d2 minus d1 by L as a constant. तो आप इसको लिख सकते हो d1 plus kx. ठीक है, फिर उसको integrate करोगे and you put the value back into the equation, you will get this. Okay. So beta, if you want, you can do the integration on your own and you can see you are going to get this equation del L equal to PL upon pi by 4 d1 into d2 into e. This is the change in length of a circular tapered bar. Now understand beta, if you want to remember this equation, very simple trick. If the cross section is constant, then what is the equation? PL upon AE. And what is the area of circular bar? Pi by 4 d square. So PL upon pi by 4 d square into E. Now in case of circular tapered bar, instead of d square, you have to write d1 into d2. Instead of d square की जगह क्या कर देना है? d1 into d2. ठीक है? So just apply the equation of delta L that you remember. Just apply the equation of delta L that you remember. PL upon pi by 4 d square into E. But instead of d square, you have to write d1 into d2. That's all you need to do and you will get the equation of delta L. Is this clear to everyone? क्या ये clear है सबको? क्या ये clear है सबको? Yes, yes, yes. Very good beta, very good, very good. So you can remember the equation in this term. PL upon AE के term में याद करो, area में pi by 4 d1 d2 लिख देना, ठीक है? Now, in the same way, Can we find the elongation of a rectangular tapered bar? Yes, we can find the elongation of a rectangular tapered bar. How we can find the elongation of rectangular tapered bar, beta? Understand. So beta, I am going to do the same thing here also. I am going to consider a very small element. मैं यहां पे भी एक बहुत ही छोटा एलिमेंट कंसिडर करने वाला हूं. मैं यहां पे भी एक बहुत ही छोटा एलिमेंट कंसिडर करने वाला हूं. आई एम गोइंग टू कंसिडर अ वेरी स्मॉल एलिमेंट हियर ऑल्सो. ठीक है, सॉरी. So I am going to consider a very small element here also, beta, and this element will be at a distance x from here, and इसकी thickness कितनी हो जाएगी? dx. Okay. Now beta, for this element I can write this equation. Delta L equal to P into dx divided by what will be the area? अब बेटा यहां पे ध्यान दो, एरिया क्या हो जाएगा? Let's consider that the height of element is b. Let's consider the height of element is b. So height is changing from b1 to b2, but the thickness is constant. So what will be the area beta? ये area कितना हो जाएगा? What will be this area? This area will be b into t, right? ये area of element will be b into t. तो बेटा this will be b into t into e. ठीक है, this will be b into t into e. तो यहां पे देखो एरिया जो है वो एक्चुअली कांस्टेंट नहीं है, b1 into t से b2 into t तक वैरी कर रहा है. एरिया इज वैरिंग फ्रॉम b1 into t. दिस इज द क्रॉस सेक्शनल एरिया. This is the cross sectional area. Okay, this is the cross sectional area, b1 into t to b2 into t. But beta, if I assume a very small element, I can assume that area is almost constant, b into t. And if I integrate it from 0 to L, I will get delta L. Now how to find the value of b? So I will do the same thing as I did earlier. मैं वही चीज यहां पे भी रिपीट करूंगा. Okay, so this is b, right? अब यहां पे ध्यान दो बेटा, note this down. This is b1, this is b2, and this is b. Okay, can you see the similarity between this diagram and this diagram? It is the same diagram, only instead of b we have b, which is the height. Okay, b क्या है? b को मैं height को मैं b से represent कर रहा हूं, right? height को मैं b से represent कर रहा हूं. So beta, now the equation of b will be similar to equation of d we got. So b will be equal to b1 plus b2 minus b1 by L into x. So beta, here delta L will be equal to 0 to L p dx divided by b1 plus b2 minus b1 by L into x multiplied by t multiplied by e. And if I integrate this equation, I am going to get this delta L equal to PL divided by b2 minus b1 divided by natural log of b2 by b1 into t into e. And there is a very simple trick to remember this also. इसको भी याद करने की एक बहुत सिंपल ट्रिक है. What is the trick? If there is a rectangular cross section bar and you are applying a force, then what will be delta L? If it is constant, it will be PL by A, and A will be B into T, height into thickness, है ना? PL by height into thickness into E. Now beta, everything is same, only instead of B, you have to write b2 minus b1 divided by natural log of b2 by b1. Is it clear to you? Is it clear to you? क्या ये चीज क्लियर है? क्या ये चीज क्लियर है? Is it clear? Yes, yes, clear है. b will be replaced by b2 minus b1 by natural log of b2 by b1. Okay, so in case of circular tapered bar, how you can remember the formula? D square को replace with d1 into d2. In case of rectangular tapered bar, how you can remember the formula? Height को replace with b2 minus b1 by natural log of b2 by b1. The rest of the formula will remain the same, PL by AE. Only in case of d square write d1 d2, and in case of b write b2 minus b1 by natural log of b2 by b1. Is this thing clear to everyone? क्या ये चीज clear है सबको? Yes, yes. Thank you so much, Ashish. Thank you so much, buddy. Thank you so much. Yes, yes, very good, very good. So beta, we have derived the equation of rectangular tapered bar as well as circular tapered bar. Now the derivation was just to understand how to get this equation. Otherwise, for numericals you need to memorize this equation. Derivation was only to explain how we found this equation. Otherwise beta, you need to memorize this equation, because in exam you will get direct questions and you will have to put the formula. Okay, so what kind of questions can you expect? This kind of questions you can expect. Okay, let's solve this question. A bar tapers uniformly from diameter 3D at A to diameter D at C, and then it is constant up to D. The total change in length of the bar is, you need to find the total change in length of this bar beta. Find the total change in length of the bar. There are two forces, one here and one here. Okay, and the bar is made of a tapered cross section, then a constant cross section. So calculate what will be the total change in length. Calculate what will be the total change in length. जल्दी से solve this question and find what will be the total change in length, and hit the like button. The number of likes are very less today. क्या कर रहे हो? Like पे like ठोको. I need 1 like from every one of you. Okay, चलो जल्दी से calculate the total change in length बेटा. Find the total change in length. What you will do? In order to find the total change in length, you will divide this entire bar into how many parts beta? You will divide the total bar into 3 parts. Okay, AB, BC and CD. AB is a tapered bar, BC is a tapered bar, CD is a constant cross section bar. Ab beta, this diameter is 3D and this diameter is D. What will be this diameter? ये diameter कितना होगा? Apply similar triangle लगा दो बेटा, and this diameter will be 2D, है ना? ये 3D है, ये 2D है, और ये क्या है? ये अपना D है. ओके, 3D D, और ये सेंटर पे है, so 2D. ओके, now delta L from A to D will be equal to delta L of AB plus delta L of BC plus delta L of CD, right? Ab delta L of AB is a tapered bar. Now consider a cross section, consider a section here. What will be the force in AB? AB में कितना force आएगा बेटा? P tensile, 2P compressive. तो AB में force will be minus P, right? AB में force will be minus P. ठीक है, AB का force will be minus P multiplied by length of AB is L by 2 divided by pi by 4 3D into 2D, pi by 4 3D into 2D, pi by 4 D1 into D2 multiplied by E. ठीक है, so this is what change in length of AB, PL upon pi by 4 D1 D2 into E, PL upon pi by 4 D1 D2 into E, right? Then BC के लिए भी formula will be same, and if I take a section in BC, what will be the force? राइट से देखो बेटा, देयर इज ओनली वन फोर्स P. सो व्हाट विल बी द इक्वेशन? व्हाट विल बी द इक्वेशन? इट विल बी प्लस P into L by 2 divided by pi by 4 D 2D, D1 D2 D 2D. तो ये हो जाएगा pi by 4 D into 2D into E. So this is the change in length of BC plus change in length of CD. Now CD is a constant cross section bar, and if I take a section, there is only one force on the right, P. So beta, what you will get? What you will get? You will get PL upon pi by 4 D square into E. So can you add and find out what will be delta L of AD? Can you add and find out what will be delta L of AD? निकाल लो, निकाल लो, निकाल लो जल्दी. Find out what will be delta L of AD. Internal force in AB will be how much? Total force right से देखो बेटा P और 2P. So plus P minus 2P minus P. BC में right side only P. CD में right side only P. तो minus P, P and P. ठीक है? Now calculate what will be delta L of AD. What I am going to do is I am going to take PL upon pi by 4 D square into E common. ठीक है? तो यहां पे क्या बचेगा बेटा? This will become minus 1 by 12. ठीक है? यहां पे क्या बचेगा बेटा? This will become 1 by 4 and this will become 1. है ना? So बेटा what you will get? What you will get? कितना आएगा? Minus 1 by 12 plus 1 by 4 plus 1. 7 by 6. Are you getting 7 by 6? Delta L of AD will be minus PL by pi by 4 D square E into 7 by 6. तो 4 ऊपर गया और 4 ऊपर गया तो ये कितना आ जाएगा बेटा? ये कितना आ जाएगा? 4 ऊपर गया तो 7 PL by pi by 4 D square E. 7 by 3 आएगा ना? 7 by 2 सॉरी नहीं. This will become minus 4PL into 7 by pi D square E into 6. तो minus 7 by 3 आ रहा है. अच्छा सॉरी 14 by 3. अच्छा पॉजिटिव आएगा, पॉजिटिव आएगा, पॉजिटिव आएगा, माइनस नहीं आएगा. तो ये हो जाएगा 14PL by 3 pi D square into E. कितना आ रहा है? Are you getting this? 14PL by pi D square into E, pi 3 pi D square into E. 14 by 3 आ रहा है. Yes, very good, very good, very good. So answer is D. 14PL by 3 pi D square E. 14PL by 3 pi D square E. Yes. चलो बहुत बढ़िया, बहुत बढ़िया. यस वासुदेव, यस 14 by 3. यस सबका आ रहा है 14 by 3. ओके ओके ओके. सो बेटा you can see that there will be direct formula based questions. So you need to remember the formula of circular tapered bar and rectangular tapered bar. Circular tapered bar का formula और rectangular tapered bar का formula आपको याद रखना है, तभी आपसे क्वेश्चन बनेगा. Otherwise you will not be able to solve the question. Is this thing clear to everyone? क्या ये सबको क्लियर है? क्या ये सबको क्लियर है? बेटा माइनस P क्यों आ रहा है, प्लस P क्यों आ रहा है? I have already explained in yesterday's class. ठीक है, तो आप लोग देख सकते हो. If you don't know the sign convention, I have already explained this. I am not going to repeat last class concept in today's class. ठीक है, कल की क्लास का कॉन्सेप्ट आज रिपीट करूंगा. तो बेटा ऐसे फिर 1 साल लगेगा आपको पूरा सब्जेक्ट खत्म करने में. ओके, सो बेटा इफ यू वांट टू अंडरस्टैंड इट, इफ यू हैव नॉट अंडरस्टूड इन लास्ट क्लास, go and repeat the last class again. अगर आपको लास्ट क्लास का कॉन्सेप्ट नहीं समझ में आया है तो आप लास्ट क्लास वापस जाके फिर से रिपीट करो. दैट इज द ब्यूटी ऑफ दीज ऑनलाइन लेक्चर्स. यू कैन सी दैट अगेन एंड अगेन अंटिल यू अंडरस्टैंड इट. ओके, सो बेटा वापस से जाओ लास्ट क्लास में और फिर से देखो, तब तो आपको समझ में आएगा. आई हैव ऑलरेडी एक्सप्लेन हाउ टू कैलकुलेट इंटरनल फोर्स यूजिंग 3-4 क्वेश्चन. 3-4 अलग अलग क्वेश्चन हमने किए हैं इंटरनल फोर्स निकालने के ऊपर. And still if you don't understand why there will be a minus p here, then how am I supposed to go further in the class? आगे के सवाल कैसे करेंगे? Clearly you can see that if I take a section, there are two forces on the right side, 2p and p. P is tensile, 2p is compressive, so it will be p minus 2p. How many times do I need to repeat this simple concept? कितने बार और आपको यहाँ पे इस कॉन्सेप्ट को रिपीट करके बताना पड़ेगा? How many times? If you have not understood yesterday's class, go and see that class until and unless you understand how to calculate the internal force. जब तक internal force निकालना नहीं आएगा, तब तक how to calculate stress and how you will calculate the elongation. Thank you so much, Shadab. Yes, very good. Beta, you see the last lecture again. Otherwise, nobody will explain. Nobody can explain. Okay. All right. So, beta, today's class we have seen how to solve problems of statically indeterminate bars of this type. Today we saw questions based on this type of statically indeterminate bar, and then we derived the equation of elongation in circular tapered bar and rectangular tapered bar. Okay, now there is one more topic related to this, and that is the elongation of prismatic bar due to self weight. Okay, तो ये self weight के question करने हैं, and then we need to solve problems related to multi-axial loading also, but the time is up for today, so I am going to solve these problems in next class. So next class will be on Monday, and on Monday we are going to start problems related to thermal stress. Next class से we are going to start problems related to thermal stress. ठीक है, thermal stress is a very interesting topic, and I am going to explain various types of numericals related to thermal stress. Okay, so next class on Monday is going to be really important for you, because beta we are going to solve various types of different types of numericals of thermal stress. And a very important announcement, from the next week onwards we are going to start daily practice problem session, DPP session, where we are going to solve additional problems of strength of material. The problem which we are not able to solve in the class, we are going to solve those problems on Unacademy free special classes. Okay, so beta I will arrange these DPP sessions for you. And beta, if you want to download the lecture PDF, just go to tinyurl.com/approve10. There are folders of ebooks, there are Excel sheets. In these Excel sheets you will find the link of the PDF. I have an Excel sheet for machine design, I have an Excel sheet for engineering mechanics, and just like that I have an Excel sheet for strength of materials. So go and open this Excel sheet and you can download the PDF of this lecture. Okay, and if you want to study with me in a more personalized manner, if you like my teaching, if you like to study more with me, if you like to spend more time with me, if you like to interact more with me, then just come to Unacademy Plus. Take the Unacademy Plus subscription. What will be the benefits of Unacademy Plus subscription, beta? You can see that how interactive Unacademy Plus sessions are. You will get live polling and leaderboard. What is live polling and leaderboard? Whenever there is an objective type question, A, B, C, D are the answers, then we will create a live polling where you can choose the right answer. Let's say I am putting the B as answer, and then we will show you what was your rank among the other students and what was your response time. you will get the response time, you will get the rank among the students. So this is called the leaderboard. So there will be live polling, there will be leaderboard. Okay, so you can understand how interactive and how competitive will be the environment. Then beta, live interaction with the teacher. You can chat live and your teacher will see your comments and answer. Okay, there will be dedicated doubt solving session. So you can see that this is a doubt clearing session. This is a doubt clearing session. Every fourth lecture on Unacademy is a doubt clearing session where you can send your doubts as an image. You can just take the picture of your doubt, you can send it to your teacher and your teacher will solve that doubt live in the class. Your teacher will solve that doubt live in the class. So this is how interactive and personalized the learning is on Unacademy. And beta, there will be multiple batches. There will be multiple batches for you based on what exam you are preparing for. So you can prepare for multiple exams, GATE, ESE, any PSU exam. There will be separate batches for all of them. There will be multiple branches. So beta, one subscription and you can attend classes of multiple branches. So if you are preparing for GATE from two different branches, let's say ME plus XE, this is just an example, you can attend the classes of ME, you can attend the classes of XE also. You don't need to take separate subscription for ME and XE. So if you are preparing with two different branches, then beta, take Unacademy plus subscription, you can attend all the classes. And you can attend the classes of multiple exams. There will be batches for GATE, there will be batches for ESE. If there is a PSU exam, let's say Vizag Steel or Coal India or BARC or DRDO exam, then there will be a batch for that. You can attend that batch also. So there is no limitation on how many number of batches you can join. You can join multiple batches, infinite, unlimited batches. Okay. So beta, what you need to do to take the subscription? Just go to your Unacademy learning app. Download the Unacademy learning app from Play Store. Then click on this plus. Choose your category, GATE and ESE, and click on Get Subscription. Then you will go to this page. Beta, there is 1 month, 3 months, 6 month subscription also. This is a short term subscription, not for you because you have a long term plan. So even if you are preparing for GATE 21, it doesn't mean you have only 3 months. No, you can still take 1 year or 2 year subscription. Why taking 1 year or 2 year subscription? Understand. First of all, 1 year subscription and 2 year subscription will cost you less per month. Look at this, 1 month subscription 5,000 per month, 1 year subscription 2,000 per month. So beta, per month cost will be very less. Okay. Second thing, if you are preparing for GATE 21, then also if you take 1 year subscription, you can prepare for ESE. Next year there will be ESE in July. You can prepare for PSU exams. Next year beta, in the month of April and May, you will get DRDO exam, you will get ISRO exam, you will get BARC exam, then you will have Coal India, Vizag Steel, other PSU exams. So you can prepare for all these exams if you take 1 year subscription. Okay. Don't forget to use this code APPROVE10. This is the referral code you need because you will get a 10% instant off. So your 1 year fee will be only 22,500 and 2 year fee will be only 27,000. And the moment you use this code, you will be connected directly to me. I will get the notification that you have used my code and beta, I will guide you, I will interact with you, I will personally mentor you, and together we are going to prepare for your goal. And the best thing is you can pay this fee in EMI also, and that is a no cost EMI. Means if you are paying 22,500 in 1 year, then it will be 22,500 divided by 12, 1875 rupees per month. So no additional cost, no extra cost. You can pay this fee in EMI also. All you need to do is use this code APPROVE10 and get connected to me. Thank you so much for watching beta. Now from tomorrow we are going to start a weekend batch. So if you want, you can join that weekend batch also. If you want, you can join the weekend batch also. Thank you so much guys. Thank you so much. Thank you so much. Very good Ashutosh. बहुत बढ़िया, बहुत बढ़िया. Thank you so much buddy. Thank you so much. Okay, okay, okay. Chalo, chalo, chalo. So beta, I will see you tomorrow in the weekend batch if you want to join the weekend batch. Okay. From 7 p.m. to 10 p.m. we are starting strength of material in weekend batch. So that's a separate batch for second year and third year student. So if you are a second year or third year student, beta, you can join that batch also. Okay. Thank you so much. Bye bye. Good night.